What's happening, everyone? In this video we'll be covering the built-in list object in Python 2.7. Though, note that all the list methods and information conveyed in this video should be completely applicable to Python 3 and above. The list is the essential data structure in Python and will be used in nearly every single piece of code you write, be it a small desktop script or a full-fledged application. In the beginning of this video we'll cover the basics of the list object, and towards the end we'll open up a coding editor and implement some of the ideas in Python code. As always, make sure to throw me a like and subscribe to the channel if you'd like to stay up to date on Python coding. Let's get started. So, to start off with, a list is essentially a way to store elements in an ordered sequence. If you have experience in other coding languages, this is akin to an array, though lists in Python offer far more functionality and mutability than basic arrays. Obviously with the downside that they're a little bit slower. You can declare a list using the simple bracket syntax, wherein you place the items you'd like the list to contain within the two brackets, separated by commas. So for example, here our first line we're just declaring an empty list because we have two brackets but nothing inside of them. On this line we're creating a list with one element, that one element being a 1. And as you can see on these two lines we're creating lists with multiple elements, and in between each element you want to separate it with a comma. And the last line here kind of covers a broader idea. Lists in Python can pretty much contain any object. So you could declare a custom class and put that into a list where the next index in the list is just an integer. So each element in the list doesn't have to be of the same type, and any type pretty much can be stored in a list. Once you've created your list, you can add elements to it using either the append, extend, or insert function. The three insertions on this slide all utilize the append function. The append function, which takes a single input element, extends the length of the list by 1, and inserts the past element at that new position. This is the most common way to add elements to a Python list. So as you can see, once again, we're creating an empty list on the first line, and on the next three lines we're appending 1, 2, and 3, and then we're printing the list, and as you can see, it's simply a list containing 1, 2, 3. So every time you append something, it's pushing that element onto the end of the list, after increasing the size of the list by 1. The insert function is fairly similar to the append function. It takes two arguments, the first being the index at which to insert the element, and the second being the element itself. Valid insertion indices begin at 0 and can be as high as the length of the list itself. If you provide an index which is greater than or equal to the length of the list, the insert function becomes the same as the append function. Thus, it'll extend the length of the list by 1 and insert the new element at the end. On a side note, realize that you're almost always going to be using the append function. I haven't come across many scenarios where the insert function was necessary. So either way, I'll walk you through the contents of this slide. So obviously in the first line we're creating a new list of length 3 with elements 1, 2, 3. On these lines we're doing 3 insertions, the first of which we're inserting the string 4 at index 0, the second of which we're inserting the string 5 at index 1, and on the third line we're inserting the string 6 at index 2. And so remember that every time you're inserting something, you're increasing the size of the overall list. So now on the last line, we're printing out the contents of the list, and we can see we have our 3 new elements, 4, 5, 6, and then we have our original elements 1, 2, 3 at the end. The third and final function we can use to add elements to a list is the extend function. This one is different from append and insert in that it actually takes another list as its only parameter. The extend function will stick the list you pass as the parameter onto the end of the original list, effectively concatenating the two lists. So here we have our list with integers 1, 2, 3. Here we're declaring another list called B with integers 4, 5, 6. And here we're extending B onto the end of A. So this is going to be changing the A list while leaving the B list the same. And here we're printing out A, and you can see we have our original 1, 2, 3 here on the left 3 elements. And then we have effectively stuck B onto the end of A. So we've doubled the size of A by extending B onto the end of it. You can access elements in a list using the same syntax you're used to with arrays, if you have experience with another coding language. To get a copy of one of the elements in a list, you simply write out the name of the list, so A in this case, an open bracket, the index you wish to access from, so 0 in this case, and a closing bracket. Valid indices range from 0 up to the length of the list. If you pass an integer greater than the length of the list, you'll be returned an index error, and if you're running a script, it will close out. As you can see from the bottom of the slide, Python also provides a unique negative index feature, wherein you can access elements starting from the end of the list. For example, passing an index of -1 will return you the last element in the list, -2, the second to last element, and so on. Python also provides a simple bracket syntax we can use to access multiple elements of a list. Note that when accessing multiple elements, we'll be returned another list, not a single element. To access multiple elements, we'll introduce a colon and a second number into our bracket access syntax. The first index is used to specify where to start reading from, and the second where to end reading from. So we can see we're cutting out the first element here by specifying we want elements from 0 up to 1, and we're just returned the first element. On this example, we're slicing from the beginning of the list to the second element, so we're returned 1, 2. And same idea for the third one here. We're accessing from the first element all the way up to the third element, so we're returned 3 elements. If we leave the colon but omit either the first or second index, we'll be returned a sublist which either begins at the beginning of the list or ends at the end, respectively. This is an extremely useful feature of the list object, and I definitely recommend implementing it in your future code. In my prior video covering the string object, I forgot to mention that this feature is also available for strings, so keep that in mind if you're coming from that video. So similar to the last slide here, we have 3 examples where we're cutting out sublists of the overall list A here with 6 elements. In the first case, we're going from the beginning of the list up to the third element. In the second example, we're going from the third element, not inclusive, to the end of the list. And then in the third example, obviously we're just going from the beginning of the list to the end of the list, so we're just returned the original list itself. We can set individual elements of the list in a similar syntax to what we use to access individual elements. Once again, we simply write the name of the list, an open bracket, the index we'd like to change, and a closing bracket. We then write an equal sign and the new element we wish to place in the list, in this case 7. Valid indices range from 0 up to the length of the list minus 1, obviously because we can't change an element that's already outside of the range of the list. Thus, if we enter an index greater than or equal to the length of the list, we'll be returned another index error. We can also take advantage of the negative indexing Python feature to place elements starting from the end of the list. So in this example, we're placing 9,000 at the last position in the list using the negative indexing feature. On this slide, we can see some of the built-in list functions. Take a moment and pause the video now if you'd like to jot some of these down. In the next section, we'll open up a coding editor, and I'll introduce you to some of the ways you can handle coding with lists, including iteration, deletion, and so on. We'll also go over the info we've covered thus far in actual code. So now that we've got our coding editor open, we can just go through some examples here. First, we can just create an array called A. Just put in some elements 1, 2, 3, and then we'll just print this out to show how the print syntax looks when you're using a list in Python. So we'll switch over to our terminal, print this out, and as we can see, it's exactly as we would expect, 1, 2, 3. One of the most important things you're going to be doing with a list likely is iterating over it and using the elements in the list to perform some function. So that is super simple to do in Python. Once again, we can just create an array here. Do 1, 2, 3, 4. Now the syntax for iterating over this is as simple as for element in A. And element here is just a variable name. You could replace this with any name you want. If you don't want it to store any value at all when you're iterating over, say for example if you just wanted to iterate over for the number of times that there's an element in A or the length of A, you could just replace this with an underscore and it won't be stored. But for now we'll just do element, and we can just print out the element and then switch over to our terminal, run that. As you can see, we have all of the 4 elements of our list printed out. Another way you can iterate over the elements of a list is by using indices. So for example, we could write for I in range length A, print A at index I. This will do the same thing, just with a little bit more explanation as to what's actually going on. So obviously we have the same result here. To walk you through this, the first thing we're doing is we're fetching the length of A, which is just going to be 4 because we have 4 elements. And then the range function basically takes in an integer input, so in this case 4, and then blows that up into 0, 1, 2, 3. So you could also do range with 2 inputs, so you could specify 0 up to length of A, and that's going to be the same thing. Or you could have it spanning from length of a up to like any other integer like 10, and then you're obviously going to have 6 iterations. But this is the most simple way to do it. So you have this, and then you have for element in a, print a. These are going to be probably the two main ways you're going to be iterating over lists in Python. So now if you have two lists, and they may or may not be the same length, and you want to iterate over them, taking out elements at the same index on each iteration from both lists, Python also provides a very simple way of doing that. So say if we had b is equal to 5, 6, 7, 8, and say for example on the first iteration we want to have a of 0, which is 1, and b of 0, which is 5, and then keep on doing that all the way up. So on the second iteration you'd have a of 1, which is 2, b of 1, which is 6. All we have to do is write for, and then these are just two variable names, so we'll just do lm_a, lm_b in zip a, b. And so this is going to be tying the two lists together, effectively making it so that you can iterate over them as one entity. And then here we can just print out the elements if we'd like. So we could say print %d, %d, %lm_a, lm_b, and this will print out each one, each iteration as we would expect. So obviously we have 1, 2, 3, 4, and 5, 6, 7, 8. So it's kind of twisting the two lists together when you use the zip function. And if you're confused by the syntax here I'm using for print, post a comment. Maybe I'll do another video on string formatting using the print function. But essentially, %d just signifies an integer, and then obviously I have two of those separated by a comma. And then we're using lm_a for the first %d and lm_b for the second %d. So it's basically just inserting two integers into this string, which just separates them by a comma. If we'd like to delete an element of the list, a way in which we can do that is by calling the del function. And then we specify the name of the list and the index at which we'd like to erase. So if we specify a of 0, well, first we'll print out a, delete the 0th element, and then print out a again. We can see how this works. So as you can see, we've successfully deleted the first element because the second print doesn't have the 1 in it. And so the indices you can provide go from 0 up to the length of the list minus 1, which is the index of the last element in the list when you're using the del function. If you're trying to implement a pseudo stack or a pseudo queue, which is basically the same as a list, but you're only allowed to access the last element or the first element, and you're only allowed to append to the end or insert at the beginning, respectively. You could use the built-in pop function of the list. So if we print out a.pop, this will print out 4 because basically it's going to pop off the last element. So this actually does two things. It's going to print out 4, obviously, like we said, because it's the last element, but it's also going to change a so that a is now only of length 3. So a then will only contain 1, 2, and 3. So we can first print out a, print a.pop, then print a again. And we should see a shorter list the second time. Yeah, so there we go. So after popping off the 4, we're able to print the 4, but then we no longer have the 4 in the original list. If we'd wish to search a list for a certain element, we can use the built-in .index function, where we pass in the element we'd like to search for. So for example, we could pass in a 3 and print this out. And this is going to be returning the index of the first instance of 3 in the list. So obviously this is going to be 0, 1, 2. It should return 2. And we can switch to the terminal to test this out. And we see it does return 2. I believe if there's no instance of the element in the list, it'll throw an error. So we could try 5, switch over to terminal, run that. And as you can see, we get a value error because 5 is not actually in the list. So if you're trying to implement that in your code, but you're not sure if there actually is that element in the list, you might want to throw that inside of a try catch block just to make sure that your code doesn't crash if you call the function and there isn't actually that element in the list. So the way you would do that is just by doing try and then except just print element not in list. And so this isn't going to throw an error, it'll just print out our print statement there. If we'd like to sort a basic integer list, Python provides a built-in sort function, and it's as simple as a.sort. So if we want to, we can print out a. Here I've changed it so that we're not in sorted order any longer. We have 4, 3, 2, 1 rather than 1, 2, 3, 4. We can call the sort function, and then we can print out a again, and it should be sorted. Yep, there we go. So now we had the unsorted version and the sorted version. I've created a small function here, provided an input x just returns x squared. And I'll use this to show you list comprehension, which is a more advanced list topic in Python. It's a really neat way of creating lists that basically mirrors the way you would write it if you were writing a mathematical document. So this is kind of just a simplified way of doing it, but we can write out a is equal to brackets f of x for x in range, and then we can specify however many inputs we want. So in this case, we'll just do 10. If you wanted to provide a specific list of inputs, you could do like b is equal to 1, 7, 4, 3, 9, and then you could just do a is equal to f of x for x in b, and then this would be iterating over all the elements in b. But for this example, we'll just do elements in the range of 10, so this is going to be 0 up to 9. And then we can just print out a and see how it looks. There we go. So now we have all of the integers from 0 to 9 squared in a list here. Another one of the more basic functions we could use built into the list object is the reverse function. And what this will do is just basically in place, so in the same list, it'll just reverse the indices of every one of the elements. So here we can just print out a again, call a.reverse, and then print a again, and we should have the same list but in reverse order. So we'll switch over to the terminal and print that out. Another simple one is a count function, and this is going to be printing out the number of instances it finds of the parameter that we pass. So if we do a.count 4, as you can see I've added in an extra 4, we should be returned 2 because there's 2 instances of 4 in the list. So here I've created a simple example class just with a constructor function that sets an internal value equal to 10. And we'll use this as an example of how you can basically add any data structure to a list in Python. So we'll just create another list here, call it a, make it empty. And then let's say we want to create 10 of these example data structures and put them all on the list. So we'll just say for underscore in range 10. And recall, underscore is going to not store a value. So normally if you did for I in range 10, I would then be set to 0, then set to 1, then set to 2, etc. all the way down till 9. But with underscore, we're not actually saving any value. We'll say new example is equal to example, and then say a.append new example. And then if we print out a, we're not going to have as clean of an output as we would have if there was just integers or strings or any basic fundamental data type. Instead, we're going to have a memory address for each one of the elements, and the memory address is going to be where each example itself is stored. So if we switch over to terminal and print this out, we'll see we have a list of memory addresses or the locations of the instances themselves in memory. And guys, I think that's going to be it for this video. I hope you enjoyed it. If so, make sure to throw me a thumbs up. If you have any suggestions on future videos, future data structures to cover, or new series in general, post a comment, and I'll be sure to read those. Or if you have any questions, also don't hesitate to post a comment. If you found any errors in any of my code or any of my examples, be sure to let me know. Yeah, so I hope you enjoyed it. Subscribe to my channel if you want to see more of these in the future. and I'll see you in the next video.